So we need to simplify the given trigonometric expression, which is sine squared a plus sine squared of a minus b minus 2 times sine of a times cosine of b times sine of a minus b. Let us begin. Now what we'll do, before simplifying it, first we will expand sine of angle a minus b. So sine of a minus b, that's a standard form. We have sine of a times cosine of b minus cosine of a multiplied to sine of angle b. Now that means we can rewrite our given expression as sine squared a plus, now in place of sine squared a minus b, we're going to rewrite it as sine of a times cosine of b minus cosine of a times sine of b, and then square it. Then we have negative 2 times sine a times cosine b multiplied to sine of a minus b. So we're going to replace it with the expression for sine of a minus b, which is sine of a times cosine of b minus cosine of a multiplied to sine of angle b. Fine. Let's further simplify. Now we have sine squared a plus, so we are going to expand this by using a minus b whole squared, which is simply sine a times cosine b whole squared minus 2 times sine a times cosine b multiplied to cosine a times sine b added to cosine of angle a times sine of angle b whole squared minus, now we're going to distribute 2 times sine a cosine b with the two terms within the parentheses. So we're going to get negative 2 times sine of angle a. So we have multiplied to sine of angle a, so that becomes sine squared a, and cosine of b also gets multiplied to itself twice, so we have cosine squared b. Then we have negative 2 sine a cos b multiplied to negative cosine a sine b, so we're going to get positive 2 times sine a times cosine a multiplied to cosine b times sine b. Right. Now let's further simplify. Now we have sine squared a. Now immediately we can see here that this particular term, negative 2 times sine a cos b cos a sine b, and this term, the last term, they will get cancelled out because they are additive inverse of each other. So we are now left with sine squared a, and the second term becomes sine squared a times cosine squared b. Then we come to the third term. So this will be cosine squared a multiplied to sine squared b. And then we have this term, which is negative 2 sine squared a multiplied to cosine squared b. Now, the second term and the fourth term, they can be also combined. And this is going to give us, so we are going to get sine squared a minus sine squared a times cosine squared b added to cosine squared a times sine squared b. So here we have combined the second term and the fourth term to get negative sine squared a cosine squared b. Now what we'll do, we'll consider the first term and the second term. Now we can see that sine squared a is common to both of them. So if we take sine squared a as the common factor, and then we will have we have sine squared a multiplied to 1 minus cosine squared b plus cosine squared a times sine squared b. Now we can replace the value of 1 minus cosine squared b with sine squared b. That's because we know that there's a standard identity, sine squared theta plus cosine squared theta, so that's equals to 1. So in a case theta is b, so that means 1 minus cosine squared theta, this is equivalent to sine squared theta. So we can replace 1 minus cosine squared b with sine squared b. Right. Then we have the second term, which is cosine squared a multiplied to sine squared b. Now we have two terms. In these two terms, the sine squared b is the common factor. So let's take this as the common factor. So we have sine squared b. So from the first term, we'll be left with sine squared a. And in the second term, we'll be left with positive cosine squared a. So this value, this is a standard identity, which is equals to 1. So theta is represented by angle a. So we're going to get sine squared b multiplied to 1. So that means our final result is sine squared b. So that means the value of the expression sine squared a plus sine squared of a minus b minus 2 times sine A times cosine B times sine of A minus B. So this is having a value of sine squared